Hello, welcome everybody to our little lesson here today on chemical reactions. We're going to go over some very basic parts here, and then we'll turn you loose on the homework. Alright, so first thing we need to talk about is what a chemical reaction is. Remember, or basically the basics of them. Chemical reactions occur when one substance changes into a new substance. So we have for example, here we have iron and we have oxygen. Okay, oxygen here is O2 because it is a Brinkelhoff, remember? Okay, those are our diatomic molecules. Now, if we have iron plus oxygen, that turns into iron oxide, otherwise known as rust. Okay, now there are certain signs of a chemical reaction. We have a color change, we have production of a gas, formation of a precipitate. That's one everybody always forgets. Precipitate is a solid from two liquids. Okay, that's what a precipitate is. Alright, a solid from two liquids. And then finally we have a change in heat. So if something warms up, cools down, that's a sign of a chemical change. Okay, if we think about this example here that we had, what's the sign there? The sign is the color change. Okay, remember iron is a gray or black, and rust is definitely red, or iron rust is. So, chemical equations. In chemical equations, we use certain things to signify other things. Now, the basic form is reactants and then products. Reactants are what we have to go in, and products are what we get out of our equation here. Okay, so a couple terminology, a couple of things to add on. If we have an S here, that means we have something that is solid. So I might write down Fe, and then in parentheses S, that means we have solid iron. If I have an L here, that means a liquid. Okay, an example of a liquid would be H2O. That would be water. Okay, if we have a gas, something like H, or a G stands for gas, an example of that would just be simply H2. In its gaseous form is how we would say that. And the final one here means aqueous. A-Q-U-E-O-U-S. Aqueous. And aqueous means dissolved in. Dissolved in water. Okay? So if I was talking about something, if I said NaCl aqueous, AQ, that would mean I would have had a glass of water or something, and I'd have poured some salt in here. So we had, sodium and chlorine running around. Okay, and then the final thing here, this little arrow, that means it does not mean equals, it means forms. Okay, so if we think back to our last slide here, I would say iron, and this would be a solid iron, plus oxygen gas forms iron oxide, solid iron oxide rust. Okay, that little arrow there means forms. Okay, now addressing a misconception here is that just because an equation can be written does not guarantee it will take place in a lab. That equation may need special circumstances, or it may never happen. It may be a reaction that will never happen no matter what. Now, we need to balance equations, okay? And we balance equations because due to the law of conservation of mass. Alright, if we think about an equation, if we think H2O, or water, can be broken down into hydrogen gas and oxygen gas. But if we add up the number of elements here, we see we have 2 hydrogens and 1 oxygen. But on this side of the equation, we have 2 hydrogens once again, which is okay, but we have 2 oxygens. Okay, and our oxygens here, they're not balanced. Okay, so we must balance equations. We must make sure they're balanced, and this basically is the law of the conservation of mass. Okay, and that comes from Dalton's atomic theory. Dalton's atomic theory states that during a chemical reaction, atoms are not destroyed, they are rearranged. Okay, so the amount we put in is the amount we get out. Alright, so how to balance an equation. So first off is we make a list of elements on the left and right of the arrow. We only change the coefficient. So remember, coefficient would be something, if we remember our hydrates, if we had 2H2O, that is our coefficient here. Okay. And then we fix the list. We keep on fixing, changing coefficients until our everything balances out. So let's do some examples. Okay, and that brings us to our H2O plus H2 plus O2. How do we balance this one out here? Alright, so we usually draw a line right down the middle at the arrow, and we list each element. Okay, so we have hydrogen and oxygen. We have hydrogen and we have oxygen. Then we list how many of each we have. Well, we have 2 hydrogens here and 1 oxygen there. Okay, and then for here we have 2 hydrogens and 2 oxygens. So this right now does not balance out. So we can only change the coefficients. So that means we can only put numbers in front. Okay, we can only put numbers in front to change. Alright, so our oxygens and they aren't balanced here, so we need to change that. So let's say we, to simply do that, we multiply it by 2. Well, that means we have to put a 2 in front here. So that gives us 2 oxygens now, but that 2 also applies to the H's here, so we'd have to multiply that. That means we have 4 H's now. We have 4 hydrogens. Okay, we've solved the problem of our oxygens not being balanced. We've got 2 and 2 now, but we've introduced a new problem by now our hydrogens aren't balanced. Well, this is pretty easy to fix. We take over here to the other side, we multiply our hydrogen by 2, or we add a coefficient of 2 to that, and that means we now have 4 hydrogens and 2 oxygens total. This equation is balanced. Okay, so let's go ahead and work on the next one here. We have zinc plus hydrogen chloride, or hydrochloric acid, makes zinc chloride plus hydrogen gas. So we have our elements, zinc, we have hydrogen, we have chlorine, and we have zinc, hydrogen, and chlorine. Okay, on this side we have 1 zinc, 1 hydrogen, and 1 chlorine. On this side we have 1 zinc, 2 hydrogens, and 2 chlorines. Okay, our zincs are balanced up, our hydrogens aren't, and our chlorines aren't. And just a little note here, usually you leave the hydrogens towards the very end. Hydrogens kind of have a tendency to balance themselves out. So let's balance the chlorine here. So we need 2 chlorines, so we're going to multiply this by 2. Okay, that means we're going to add a coefficient of 2 up here. Well, by doing that, we also have to add that, okay, to the hydrogens. We have to multiply that to the hydrogens also. That means we have 2 hydrogens, 2 chlorines now. Does everything balance out? You bet it does. Okay. Our last one here, okay, is FeOH3, or iron hydroxide, decomposes to iron oxide plus water. So let's go ahead and solve this one here. We have, for our elements, we have Fe, we have O, and we have H. Going to kind of spread them out there a little bit. Here we have Fe, we have O, we have H. Okay, so here how many irons do we have? We have 1 iron, we have 3 oxygens, and we have 3 hydrogens. If we look on this side, we have 2 irons, we have 4 oxygens, 3 from here, 1 from here, and we have 2 hydrogens. So we have to balance this out. Remember, as I just said a little bit ago, we kind of want to leave the hydrogens till the very, very end. Okay, so irons, we need them to balance out. So to get the 2 irons to balance out, we need to multiply this by 2. Okay, well that means we need to multiply everything else here by 2 as well. Okay, so 2 FeOH3, now let's see, that gives us 2 total, that gives us 6 total, and that gives us 6 hydrogens now total. Okay, so our irons are balanced out. Now we need 6 hydrogens and 6 oxygens. Okay, so we don't really need to change that. We do need to change up how much water we get. Okay, so to get 2 hydrogen, or get to 4 oxygens. Okay, now remember we've got 3 of them here, so really we need to change just that 1 oxygen there. So let's end up multiplying this by 3. Okay, so if we multiply this by 3 and do a recount here real quick, we have 3 times 2 hydrogens. Okay, that gives us 6. If we do the oxygens here, okay, 3 times 1 is 3 plus 3, that gives us 6 total now. Okay, I'll just scratch that out actually and go from there. Hopefully it'll scratch out. Maybe not. Okay, big eraser time then. Whoops, my bad. Okay. So we had 4 to begin with. Okay, that means we're gonna basically cross that out real quick. And so if we multiply this, 3 times 1 gives us 3 plus 3, that gives us 6 total. So are we balanced? Yes, we are. Okay, so that's our basic types, or that's our basic process to balancing equations. Going to go over one more thing here, or a couple more things real quick, and basically just give you the idea. So hopefully you can try and figure it out for your homework. Okay, let's talk about different types of chemical reactions. The first type, and I don't know if you can read this, is synthesis. Okay, and synthesis, another word for that is combination. Okay, and as we can see here, it's a very simple reaction. A plus X makes AX. Okay, very simple. So an example of that would be H2 plus O2 makes H2O. Okay, it's where we got one thing combining with another to form a product. That's pretty easy. Okay, we've also got decomposition reactions. Okay, decomposition is when something breaks apart. So AX makes A plus X. To give you an example here, we could just go backwards. H2O can decompose into H2 plus O2. Alright, a couple more types that we're going to go over real quick here. We've got single replacement reactions. Okay, right now I'm going to teach you about is how to identify them. Okay, we've got A plus BX makes AX plus B. Okay, if we think about something here, we can have sodium hydroxide plus hydrogen gas. Okay, that can make sodium metal and water. Okay, it just simply replaced one. Okay, and that's basically one replacing another in an equation. Okay, there's some examples. Magnesium plus zinc chloride makes magnesium chloride plus zinc. And if we look at this, the magnesium and the zinc merely swapped places. Okay, and we'll get into this, what makes a reaction and doesn't, in just a little bit. Alright, so let's do a couple more. Double replacement, okay, is when they both switch places. So AX plus BY makes AY plus BX. Okay, it just is where we basically have a reaction take place where they swap partners. Okay, they switch up real quick. Our last type of reaction here is a combustion reaction, and this is anytime we have a hydrocarbon plus oxygen. Okay, a hydrocarbon plus oxygen. Hydrocarbons, as the name implies, we have hydrogen and carbon. So these could be CH4, okay, C2H3. Anytime we have carbon and hydrogen, we have a hydrocarbon. Okay, now when we have a combustion reaction, combustion means it catches on fire. Okay, that hydrocarbon plus oxygen makes CO2 plus water. Okay, that's the basics of a combustion reaction. So hopefully you can be able to just identify those simple types there. I'm running out of time here on my ability to record, so we'll have to stop there for now. We'll get into this in more detail, but you should be able to do parts 1 and 2 of your homework now. I'll see you guys tomorrow. Take care. Bye.